Now let's talk about relationship set. So this is one entity set. This is another entity set, right? So customer has ID, its name, let's say it's customer street and customer city. We have removed many of the attribute because it's very big, right? So an account has account number and the balance. So as you can see, this is a primary attribute here. This is a simple or single value attribute. Here is a primary attribute and other are taken as a single value attribute. Now this is a relationship set between two entity set. And you can see that there is an attribute of the entity, the relationship set also. So the attribute is defining in the same way how we'll define the attribute of other entity, we'll define the attribute of the relationship set also. And how they are connected to each other, as you can see, many to many connections are there. It's not one to one, right? Or it is not one to many, it is a many to many, right? How we can say many to many? As you can see in the diagram, see, either in the middle there is a relationship called depositor. Here we have the customer table and here we have the account table. So the customer and the account are related to each other with the relationship which is called depositor. And this relationship is telling you that because there is no arrow, so we can say here is a many to many relationship between these two. So in this particular diagram, as you can say, there is a many to many relationship. Now let's talk about the cardinality. As I told you, many to many, many to one, how we can express those, right? So this is the way how we can represent the cardinality of one to one or one to many. This is one to one, right? Why it is one to one? Because in an entity, let's say the customer, and in another entity with, let's say, the account, has many instances, right? Many datas. Let's say the customer, there is a A1, A2, A3, A4 customer, and let's say there is an account which is B1, B2, B3, B3, B4. So one customer will have only one account, and that account will not be shared by with other customer, right? So this is the relationship. It is called one to one relationship. There is also a relationship which is called one to many relationship. Let's say we have the faculty table and the student table. So one faculty is teaching multiple students. In that way you can assume. So there's a one to many relationship, right? One to many, right? Here it is one to one, right? But overall, if we'll see, so there is a one to many relationship. Now let's talk about many to one from here to here. So you can see this is a student, this is a faculty, right? So multiple students are taking the class of one faculty in that way. Then there is a many to many relationship. So we have multiple how we can relate many to many. Let's say we have the library table, and then we have the no, in the library table also we have the books, right? So what else let's talk about faculty and the student, right? So if A is the faculty and B is the student, so one faculty is taking the class of the student B1 and B2. Another faculty is also taking a class of B1 and also it is taking the class of B1, let's say. A3 is taking the class of B3 and B4, and A4 is taking the class of B3. If we'll talk about in the reverse way, so one student B1 is taking the class from the faculty A1 and A2, right? Different subjects. He is taking the class of this faculty. Let's say that B3 is taking the class of two faculties. So here also from this side to this side we have one to many relationship, and from here to here also we have one to many relationship. That's why it is one many to many relationship. This is the how we can express it. This is the way how we can express one, and this is the way how we can express many. So if we'll talk about this particular diagram, so here we have one to many relation, right? It is written one, this is one to many relationship. So how we can say that is a one-to-many relationship. A loan is associated with at most one customer via borrow. So there is multiple loan, right? But only one customer is borrowing or is borrowing that particular loan. So we have one to many relationship. Then how we can represent this? There's a many to one relationship. Means multiple customer are borrowing the same sort of or same type of loan. And there's a relationship. It is called many to one relationship. Then we have many to many relationship that we can represent in this way. And if you do not want to use the arrow and the line, then you can use these type of cardinality values also. So this is how we can represent. So there is a what is type of participation. So this will take is a many, and this will take as a one. So there may be the customer who doesn't have any loan, right? So there is a participation is zero to n number, infinite. So many to one relationship it is. So this is the way how we can put the mapping or the cardinality between two entity set. So we know about ER diagrams, right? We'll see other thing also here. As you can see here, this is a primary attribute. This is also a primary attribute. Another attribute are single or simple attribute. Let's talk about the participation between two entity. If we have the double line, then there is the partial participation. Okay, partial participation. So what do you mean by the entity set with the total participation and the partial participation? So if we have the two lines, two solid line, this representing the total participation. Okay, so what do you mean by total participation? The meaning of the total participation is, let's say we have the different type of loans. So we have the education loan, we have the home loan, personal loan. Let's say we have or the car loan. Let's say we have four type of loan. All type of loan will be taken by the customers. All type of loan will be taken by the customer. So all loan are associated with. So that is the total participation. Now if we'll talk about customer, can we say that we have the partial participation? It means that there are maybe some customer who doesn't have any loan, who is not associated with any loan. So those customers who doesn't have any loan will not going to participate with the relationship borrower, means they are not borrower. So I have also the account in the triple IT campus, but I doesn't have any loan, so I'll be in the category of that. So I am not the borrower. So as this particular diagram, in this particular diagram we can say that there is a total participation with the loan. Okay. Then how we can define the roles? So if we have the employee entity, employee has many attributes like employee ID, employee name, street, employee city, and the employee number. And there is a relationship which is called works for. So employee may be the worker and employee may be the manager. So if we have the same entity with different role, means there is an employee, right? Employee of a company may be a worker, or employee of the company may be a manager, right? So we can define the role in this way also, which is participating with the same entity again with the works for relationship. This is how also we can represent the roles in the ER model. Then we can make the ternary relationship. Means it is not compulsory that there is a relationship. That relationship is for only two entities. That relationship is maybe n number of entities. So employee work on branches, and the same relationship will be used for job also. So this particular diagram is telling you that there are three entities, and these three entities are associated with each other through one relation only. It's a ternary relationship. Now, how we can convert the ternary relationship with a binary relationship? This is the way how we can do that. So we have the ternary relationship. Let's say we have entity A, entity B, and entity C. Now, what we can do is the B and that particular the relation we can convert into another entity which is E, and then in between we can put the relations. In that way, we can make the relationship. So here RA is relating E. So let's talk about E. Now replace R between entity set ABC by an entity E. So what we are doing is we are replacing this relation with the entity. So that relation is converted into entity, and this entity will have, then in between we can put the relationship. Now let's talk about weak entity set. Okay. Now what do you mean by weak entity set? Entity, right? Entity means your object. So what do you mean by weak entity set? The meaning of weak entity set is that entity doesn't have any primary key. Then that entity is called weak entity set. So let's say we have the student table. So can we say that a student is a weak entity set? No, student is not a weak entity set, because student has its roll number as the primary key. So if in any entity we have an attribute which has the property to become the primary key, then that entity is a strong entity. Now, which entity is a weak entity? The entity which doesn't have any attribute which has the capacity to become the primary key, then that particular entity is called weak entity set. So the entity set that doesn't have any primary key is referred to as weak entity set. The existence of a weak entity set depends on the existence of identifying entity set. It must relate to the identifying entity set via the total one-to-many relationship set from identifying the weak entity set. So what it is saying that if we have the weak entity set, so definitely the participation will be of type total always with the weak entity set, and the relationship will be one-to-many relationship. Identifying relationship depicted using the double diamond, and the relationship with the weak entity set to any type of entity set we can represent with the double um, diamond shape. So we have double diamond shape, right? So in the diagram, if you'll see, uh, we have this double diamond shape. So we'll put the double diamond shape in between any entity and any weak entity set. And how we can represent weak entity set? With double rectangle. Okay, double rectangle shape. And what should be the relationship with the weak entity set? So there will be the total participation will be there. So if we have the total participation, we'll put it, we'll say that it is a weak entity set, and it has the total participation, and the the relationship we can represent into the double dimension. Now, if it doesn't have any primary key, then what? Then there we can put any attribute as a partial key, or it is also called discriminator. So discriminator is of a weak entity set is the set of attributes that distinguishes among all the attribute of a weak entity set. So what we'll do is, because we didn't find any primary key, so we'll make the combination of one or two entities set, and we say these are the discriminator or the partial key. The primary key of the weak entity set is formed by the primary key of the strong entity set on which the weak entity set is existence dependent plus the weak entity set discriminator. So it says that the primary key of the weak entity set will be formed by the primary key of the strong entity set, right? And then we'll put together the partial key and will represent the primary key for the weak entity set. So let's talk about this weak entity set and try to understand. So as you can see, the payment here will taken as a weak entity set. Payment number here we are taking as a discriminator, and discriminator will put as a in the with the dotted underline. Then we have the loan table. Loan table has loan number, which is the primary key. There is a simple attribute. This is also, these two are the simple attribute, but as you can see, the difference between this entity set and this entity set here will represent with the one rectangle shape. Here we are representing it with double rectangle shape. So this is representing you as a weak entity set. So if we have the weak entity set, always the participation will be total participation and it will be many to one. And as well as the relationship set will also be represented into double dimension. Okay. Now let's talk about specialization and generalization way. Okay. Now there are the approaches called top-down design process, which distinguish subgrouping within an entity set that are distinctive from other entity in the set. These subgrouping become lower level entity set that has attribute or participate in relationship that do not apply to the higher level entity set, depicted by the triangle component labeled as ISA. The full form of ISA is a attribute inheritance. So here we have the concept of inheritance. A lower level entity set inherit all the attribute and the relationship participation of the higher entity set to which it is linked. So I have given you the diagram of the specialization and generalization. Specialization is top-down approach and the generalization is bottom approach. So and both will be represented by the same diagram. So if we are going from top to down, that is specialization. If we are going from bottom to up, that is generalization. Okay. So from top to down, it is specialization. From bottom to up, it is generalization. Now, if you are going from top to down, so what will happen is we can inherit the property of the entity which are there in the top and to the bottom. Let's say we have the entity called person or human being, right? So human being has some property. And if we are going to the lower level, let's say we have faculty and the student. So faculty is also having the same property which a human being will have. And the student will also have the same property which human being will have. That type of relationship can be represented as a relationship. This is called specialization. If you are going the same thing with the bottom to up, that is called generalization. Let's see the example here with the specialization and generalization and how we can represent it. So as you can see here, there is a person attribute and person has many, entity, and that entity has many attribute. Then there is a specialization. There is an employee and the customer. So person is also employee and person is also a customer. And here you can see that employee should have employee ID, right? Should have some sort of primary key, but it doesn't have. Why? Because it's taking all the property, all the attribute of that particular entity here. And customer will also take all the attribute of that particular person here. So here it is invisible because of this property. It is called specialization property. Then the employee may be officer, maybe tailor, maybe secretary, right? So this is the way, and if we're going from bottom to up, it will become generalization. The diagram will be the same. Now let's talk about aggregation. Here, if you see this particular diagram, in this particular diagram, there are relationship works on, then there's a relationship manages, then there is an entity called employee, then there is a branch, then there is a job, then there is a manager. There are different type of what entity, and there are some relationship also. Now, if you'll see, this relationship is has associated with three entity. This relationship is also associated with three entities, three, not three, four entities. Now, how you can put together in such a way so that it will look like in a good way? Can we transform this into representing into a good way? So that will be possible with the help of the concept called aggregation. So what we do is we aggregate all these the first part of it, and we'll make it as a one entity. So this what the three entity set with one relationship will put together and will make one entity, and these one entity will be associated with another entity called managers with the relationship set managers. Getting it? So that concept is called aggregation. In the implementation model, we are going to create 1, 2, 3, 4 table with two relation, right? The same thing which we'll do in this diagram. But this particular diagram looks simple. Why? Because managers is associated with all the entities. Here also managers are associated with all the entities. Getting it? That concept is called aggregation. Now we have different examples. This is an example of a banking system. So this is an ER diagram for the banking system, where we have entities called customer, employee, account, payment, loan, branch. Then we have different attributes of each entities, and then we have relationship set between entity set, right? So this is the ER diagram of any database. This is another ER diagram for exam management system, if you are making. So we have teacher, student, mark, subject, group are the entities. We have attribute. These are all different attributes. Teacher ID, student ID, group ID are, or the mark ID is the primary key attribute. Then we have the relationship. This is also an example of an ER diagram. This is for the flight management system, where we have flight, airlines, miles order, travel agency, passenger, all those are the entities. Then we have different attributes and how they are related to each other. The relationship is also given to me. Now, this is a ER model for the library management system, where we have author, book, user, publisher, message, periodical, tag, all those are different entity. We have different attribute as well as the relationship between them. So these are the different example of representing different ER models.